our lesson for today, we will be looking at chemistry 1502. The topic for today is alkynes reaction. We will be looking at the specific reaction, which is catalytic hydrogenation. Lesson 101. Let us start. If you've went through the series of alkene reaction, then you understand that before we get to the mechanisms, we talk about the general basics, whereby we just look at the simpler mechanism without getting into detail to check how we can predict the product of an alkyne. Now, before we start with this type of reaction, I want you to understand that when you talk about alkynes, we are talking about those compounds which has triple bond between carbon and carbon, and then either they can bond with other carbons or hydrogens. We call this alkynes. It's another functional group that we've covered so far. And the clear indication of an alkyne, it's simply this triple bond. So let us look at the hydrogenation. The very same thing that we've discussed in alkenes. Hydro simply means that we add hydrogen. So we are going to add hydrogen using a catalyst. Our catalyst, we can use platinum, palladium, nickel. These are the most common catalysts we're going to use, and if you can check, these are actually metals. So this is the general reaction. Whenever we take an alkyne, we hydrogenate it in the presence of catalyst. Might be one of these, so let me just put catalyst. Just know that we are going to yield an alkane. And I should take note that we need 2 of these. We actually need 4 hydrogens so that we can hydrogenate it to alkane. So the general equation, we can say triple bond bonded to R groups, presence of catalyst, we are going to have an alkane. This will specifically be hydrogens. The reason why we say we need 4 of them, you can see that we've added 4 hydrogens. So the question would be, what if we add only 2? If we add 2, we are going to result with an alkene. Before we start with examples, I want us to look at the different types of alkynes we have. Also, this information will assist us with the next lessons. So we have terminal alkynes. Remember that when you talk about terminal, we are talking about those atoms which are actually out. We have terminal atoms from the Weber theory, and then we have the central atom. The terminal atoms are the ones which are surrounding the central atom. So we have terminal alkynes. An example of a terminal alkyne. Let us take a butyne. Then we put hydrogens here. If this triple bond is not within the inner carbons, you can see that the triple bond is actually out, or we can put it here. We refer them to terminal alkynes. And then we have internal alkynes. you can see that the triple bond is within the carbons which are in the middle. And then under internal alkynes, we have symmetric and isometric internal alkynes. Suppose we have this type of an alkyne. We do agree that this is an internal alkyne. But let us look at, these are the carbons which are involved in the triple bond. And the triple bond is in the middle, meaning that it is not found in the primary carbons. So in this case, we can safely say this is an internal alkyne. But let us look at the type of internal alkyne we have. Look at the left hand side and the right hand side. We actually have an ethyl on the right hand side, we have methyl on the left hand side. So you can see that the left hand side is not the same as the right hand side. So this is an isometric or isometrical internal alkyne. If we can cleave here, you'll see that this part will not be the same as this one. And then another type of an internal alkyne, you can see this one that both sides are actually identical. There's a symmetrical internal alkyne. Let us look at our examples. Suppose we have a pentyne. Let us actually put triple bond here. We hydrogenate it with hydrogen in the presence of a catalyst. You should know that this reaction is a two-step reaction whereby we add the first 2 hydrogen and then we add another second 2 hydrogens. But writing the mechanism, because of this catalyst, you should know that it hydrogenates it straight to alkane. We are going to be looking at how to yield an alkane to stop the reaction at an alkane level. But in this case, for the sake of learning, just note that it is a two-way step. So what we do, we simply identify the carbons which are involved in the triple bond, and then we break one of their bonds so that we can add the hydrogens. When we do so, we are going to yield something like this. But remember that we've just broken this bond here. Now you can see that these carbons are no longer reaching octet rule. So what we do, we put our hydrogens, and then we can say we further hydrogenate again to form something like this. Just know that I've just removed the bond again, and then in this case you can see that each carbon that was involved in the double bond, the triple bond, is bonding 3 times. So we put our hydrogens here. Then you can see that we no longer have a triple bond, but we have a single bond, and then this will be our alkane. Let us look at the second example. We can look at butane. The question would be, what type of an alkyne is this one? You can see that this is an internal alkyne. Specifically, it is a symmetrical alkyne. So we put 2 hydrogens in the presence of a catalyst. This will give us an alkane. So it's CH3, CH2. Let me actually do this, but it's okay. CH2 and CH3. Let us look at the hydrogens which were added. We have, this is the carbons which were involved in the triple bond. So you can see that we've added the first hydrogen and the second hydrogens. You can see here that we have 4 hydrogens. So we have 2 hydrogens, 2 hydrogens, it sums up to 4. So what is important, simply look at the catalyst. You should know that it hydrogenates from alkyne to alkanes. Normally the first reactions are very simple. So in the next lesson video, we'll be looking at the practice question of this, and then we're also going to be looking at the next type of reaction of alkynes. This is Bahula SJ. Thank you very much.